Alrighty, so math is all about learning how to describe numbers and show them in many different representations. So far we've done with algebra, right? Solving for x. We've also did it on a number line. And now we're going to do something called interval notation, okay? And you can use interval, you can use an inequality such as x is less than or equal to 3, negative 3, to describe a portion of the number line called an interval. And you can use an interval notation to describe an interval on a number line, okay? So we use symbols, all right? Those symbols are going to be, pen will work. There we go. Okay, parentheses, all right, brackets, and then infinity symbols. So let me show you what that will be. All right, so when you have parentheses, this is for parentheses. Okay, that is when you have only, okay, showing me that the interval's endpoints are not included. Okay, that's the keyword there, not. Sorry folks, my pen is being extra laggy today. But for this side, use the brackets here. So this is for this. Yeah. Alright, that's when you have a less than or equal sign or greater than or equal sign symbol that indicates that the intervals endpoints are included. Okay, so this is keyword, they are included. Like that. So once again, it's very similar, right? Parentheses is very similar to like an open dot when you have it, when you graph it on a number line. And then brackets is when you have a closed dot on a number line, right? So I mean that exact number is part of the solution. So we're also going to use the symbols for infinity here. So use the positive infinity when the interval continues forever in the positive direction, and then use negative infinity when the interval continues forever in the negative direction. We're going to stick to parentheses with infinity symbols because, right, they go on forever. And there's no defined spot. It's like a bracket. So now let's look at some examples. Okay, inequality x is greater than or equal to 2. I draw it like that. So it's going to be a solid dot. And then since 2 is part of my solution, I draw a bracket. And then it goes on to positive infinity right here. Okay. So once again, close bracket, close dot, bracket. Okay. X is less than 2. So that's going to be an open dot going forever towards the negative direction, negative infinity, okay? So remember when we write interval notation right here, we always start reading from left to right. So it's going to be negative infinity, parentheses, and 2 parentheses, right? Because this is an open dot. All right. Let's look at this one, a compound inequality. 1 is less than x is less than or equal to 5. Okay, so right here you're just going to write, once again, just write the endpoints. So, okay, you're only going to write the endpoints right here. That's the main thing you need to pay attention to when you're writing interval notation. Okay, so I see that 1 is open dots, that's going to be parentheses, and 5 is closed dots, that's going to be brackets. Okay. Alright, and last but not least, you have an OR statement with compound inequality. X is less than negative 3, right? So it's an open dot towards the negative infinity, or x is greater than or equal to 4. So that's going to be a closed dot going towards positive infinity. Okay? So once again, remember, we want to pay attention to these endpoints right here. Okay, and if it goes forever towards the arrow, it's going to be the negative infinity. If it goes forever towards the positive arrow, positive infinity. Okay? Nice. Alright, so how do I make a graph for this right here? Negative 4 and 6, like that. And then I also write that in an inequality. Alright, so let's break this down. This endpoint right here is going to be a closed dot. Alright, because I see that there's brackets right there, so negative 4 is part of my solution. And then on this side, since parentheses, it's going to be open dot on 6, because that parentheses showing me that 6 is not part of the solution. Since I have two numbers combined in interval notation, this is going to be an AND statement. Okay, it's going to be an AND statement inequality, compound inequality. So that means they're going to overlap. I'm going to draw like a 0 here. Let's do 2, 4, and 6. Let's do negative 2, negative 4, and then negative 6. I'm going to draw that closed dot on negative 4, like that. Okay, I'm going to draw an open dot on 6, like that. And then, since this is an AND statement, I know that all the solutions of x for this interval notation are going to overlap. So I'll just draw a line right there, and that's my answer. Okay, how am I going to write this as an inequality? Once again, let's just remember this is an AND statement. So that will be, I know that it is less than or equal to 4. Right? And I'll call it x. But it's negative 4 is less than or equal to x, which is less than 6. Okay? That is going to be my compound inequality. Alright, so that's that. Now, let's look for this one right here. What is the graph of x is less than or equal to negative 1 or x is greater than 2? Then how do I write this in interval notation? So now it's given to me in inequality form. So let's just put on a graph. Okay, let's put 0, 1, 2. And then on this side, it's going to be 1, and 2. Alright, this is going to show me its closed dot. So it's going to be a closed dot on negative 1, going forever, towards infinity direction. Okay, x is greater than 2, so that means x cannot be 2, only greater than 2, which is going to be an open dot on 2 going forever in the positive direction. How do I write this? Okay, so this is going to the negative direction, to be negative infinity, and it's going forever in the positive direction, right? I could just write positive infinity. Right? So that would be negative infinity, comma, negative 1, brackets, right, or right there, parentheses 2, going forever in the positive infinity. Alright, and this is my interval notation. You have right here, okay? So, let me give you all a quick summary for these ones right here. So, whenever you have a less than sign or greater than sign, and you have stuff like parentheses, this is going to give you, right, an open dot when you graph it. On the other hand, if you have a less than or equal to, greater than or equal to, or a brackets, that is going to give you a closed dot on that endpoint of the interval. Okay, so just remember that as you are doing these problems. Go for it.